Hello and welcome back to the course on statistics. Today we've got a very exciting topic, statistical significance. And it's very exciting because I know that from my experience, from my career, it's a question that is always asked, or at least you ask yourself this question. Is my result statistically significant or not? Or are these insights statistically significant or not? And if you don't understand statistical significance, then it's a question that you dread from your manager or the person that you're reporting to, because you cannot substantiate your results. You found some stuff, but you don't know if it's right or wrong. And in this section, we're going to be exploring this concept in a lot of detail, and we're going to be referencing it a lot, and you will get a great understanding. Hopefully, you'll be able to build a strong understanding of statistical significance. However, in this tutorial, what we're going to focus on is on the intuition behind statistical significance, how you can link how you feel about an experiment to what actually statistical significance is. So let's have a look. All right, so here we've got an experiment, a coin toss. I know it's always a coin toss, but a coin toss is, in all fairness, a great example to get started with because it is so simple. There's only two possible outcomes, and you've already done this so many times in your life that you know kind of what to expect, and that's why it will help us build the intuition. So there are two possible versions or two possible situations, kind of like we're going to start talking about hypothesis testing right now. When we're talking about hypothesis testing, we're thinking about two possible alternative universes, if you will, if you want to put it that way. So one possible universe is that in that universe, it's a fair coin. In that scenario, in that environment, but probably I like the way to put it as in the universe. So in that universe, it's a fair coin. So that's our original assumption. That's why it's got H0. That's the null hypothesis that we're starting off with. And then H1 is the alternative universe or the alternative hypothesis, sometimes also called HA. And in this universe, this is not a fair coin. So we want to understand which universe do we live in, or which situation are we actually dealing with, or what is the truth? That's what we're trying to assess. Is it a fair coin? Is the null hypothesis correct? Or is it not a fair coin? And then the alternative hypothesis is correct. And so the way we're going to go about this is we're going to assume that H0 or the null hypothesis is true. So we're going to assume that we live in the first universe. And then based on our experiment, we're going to see if we can contradict that, if we can come to a contradiction and say, oh, actually, our assumption was incorrect. And we'll talk more about that towards the end of this tutorial. But for now, let's assume that you've got a coin that you're tossing, that somebody's going to toss just now, and you're assuming it's a fair coin. We live in that universe. So the coin is tossed the first time, and the result is tails. The question is, how do you feel about this? Forget about statistics for a second. How do you feel about this? Do you feel that this is a fair coin or the coin is rigged? You probably feel that it is likely a fair coin. This is a totally probable outcome. In that universe that we have assumed we live in the H0 universe, the probability of that is 50%. So it could have been heads, could have been tails, no problem. Then the coin is tossed a second time and it's tails again. How do you feel about this now? Do you feel that the coin is rigged, or do you feel that it's a fair coin? Well, let's look at the probability of this happening in our universe that we're living in the H0 hypothesis. The probability of that happening, if this is a fair coin, is 25%. So no big deal, could happen. Then the coin is tossed again, and again it's tails. Okay, so how do you feel about that now? What do you feel about having three coins, 3 times the same coin is tossed, and you get every single time it's tails? Well, it might be a bit suspicious, but it's fairly okay, because in our universe in which we live in the H0 universe, where the coin is assumed to be fair, this could have happened, and the probability of that happening is 12%. But then the coin is tossed again, and guess what? It's tails again. All right, so are you getting a bit suspicious now? Do you feel that if this were a fair coin, this would be quite hard for this to happen? Well, in the universe that we assume we live in the H0 universe, where the null hypothesis is assumed to be true, or where the null hypothesis is true and we assume we're in that universe, well, in that case, this could have happened with a probability of 6%. All right, and then the coin is tossed again. And again, it is tails. Now, how do you feel about it? How do you feel about seeing somebody toss a coin and them getting tails every single time, 5 times in a row. Well, you feel a bit, correct me if I'm wrong, but I'm assuming you feel a bit uneasy about that you feel that something might be going on here. Something is a bit not right, or like it's a bit suspicious that this coin has had tails 5 times in a row. And your feeling is correct. Your feeling is natural because the probability of this happening, if we assume that it is a fair coin, the probability of this happening is only 3%. So if we assume that we live in a universe where the null hypothesis is true, where the coin is a fair coin, we would have only seen this with a likelihood of 3%, meaning that you would have to watch this experiment on 33 different occasions. Like you watch it today, you watch it tomorrow, you watch it another day. You would have to watch it on 33 different days or 33 different times. So this experiment of 5 coin tosses would have to be conducted, and only once you would see this result. So it's a very low probability, and that's why your feeling of this is something's going on here is completely valid, completely justified. But then let's see what happens. The coin is tossed again, and this time it's, guess what? Tails again. I know you were probably expecting heads. No, it's tails again. What do you think is going on here? How do you feel about this coin? Do you feel that it's still a fair coin? Do you feel that our assumption that it's a fair coin is correct? Or do you feel uneasy about that assumption? Do you feel that something might be suspicious here? And if you feel that something might be suspicious here, you are again very well justified, even more than so than previously, because the probability of that happening is about 1%. 1% only. And what is going on here is that the probability of this happening is dropping as you get more and more tails. And in terms of this course, further down, we'll be operating with the term p-value. In fact, we've already seen p-values when we looked at the z-score table previously, when we were looking up the z-scores. Well, in that table in the middle, what you have is actually a p-value. So you can see that the p-value is dropping. That's simply the probability of this happening, given that we're in a universe where the null hypothesis is true. And this is very important to understand, that if we're in this universe, this top universe, then this is what the p-value looks like. It's very unlikely that you'll get 6 tails in a row. However, if you think about it for a second, if we were in this universe where it's not a fair coin, where it's for example, it's a weighted coin, or both sides of the coin are tails, that if you have a coin like that, if we were in this universe, then these p-values would be completely different. They wouldn't be like this. The p-values would be 100%, 100%, 100%, 100%, 100%, 100%. So if we lived in this second universe, we wouldn't get that feeling. We wouldn't get suspicious over here or even more suspicious over here. We would totally be comfortable with this because we know that the coin has 2 tails on each side. There's a tails on the coin, and therefore we would be totally comfortable with one tails in a row, 2 tails in a row, 3, 4, 5, 6 tails in a row. We wouldn't get any uneasy feeling about it if we lived in this universe. However, the way hypothesis testing works is that we assume we live in this universe over here at the top, the null hypothesis universe, and then we want to see, will we get, whatever our experiment is, will we get an uneasy feeling about it? And this uneasy feeling, in mathematical terms, you can't just go up to your boss and say, or your manager or your client, you can't just go and say, I had an uneasy feeling about this. I don't think it's true. Of course, you have to put it in mathematical terms, and that's where statistical significance comes in. So statistical significance is basically this line over here, as simple as that, 5%. So that's where you started getting this uneasy feeling. Just after the 6%, you started being very suspicious about things going on, and that's about right. That's because as soon as something is 5% or less likely to happen, that's the alpha here, then that is like 5% is like 1 out of 20. So that's when we draw the line and we say, okay, so it's so unlikely. I am so unlikely to see this by random that I'm going to reject this null hypothesis. I'm going to say that because I'm seeing this and it was so unlikely to happen at random, this cannot be true. And that's where you say that I'm confident, I'm rejecting this null hypothesis with 95% confidence. That I'm 95% sure that we don't live in this universe. There's a 5% chance that we do, but I'm 95% sure that we don't live in this universe. I'm going to reject that hypothesis, and I'm going to state that we live in a universe where this coin is actually rigged. And you can set this confidence level to whatever you like. You can set it to 10%, then you'd be rejecting over here. You can set it to 1%, you could be rejecting over here. So it depends on your experiment. Most of the time, 95 is a good level to go with, but sometimes, especially in medical trials and things like that, where it's people's lives depend on that, the results or the confirmation or not confirmation, or like whether or not we reject the null hypothesis. In those cases, you might want to. Sometimes it's required that you set it to 99%. So it depends on your experiment and on what you're doing with those results. But generally speaking, this is what statistical significance is all about. It's the point where, in human intuitive terms, you get uneasy about the null hypothesis being true and you get super suspicious about it. In mathematical terms, it's just where you draw the line and you say, okay, I have enough confidence, or like this is sufficient level of confidence for me to reject the null hypothesis. So I'm going to state that we live in this alternate universe. So there we go. That's kind of the intuition behind hypothesis testing, and we'll actually talk more about hypothesis testing intuition further down and throughout these tutorials. But more importantly, this was a tutorial on the intuition behind statistical significance. And as you go through these tutorials, what I encourage you to focus on is to develop a gut feel for statistical significance. So it's one thing to to calculate the formulas, write out the equations, and understand if something's statistically significant or not statistically significant. But at the same time, it's an additional benefit if throughout these tutorials you kind of think about what we were talking about here, that you don't just run the calculations and do the mathematical side of things. Also think about it from an intuitive perspective. Think about it. Do you feel uneasy about those numbers? Do you feel that something suspicious is going on or not? And then see what the mathematics tells you. And that way you will be able to slowly but surely develop this gut feel for statistical significance. And sometime, like in the future in your career, it'll be easier for you to apply these things and just look at a problem and, without even doing the math, not have an answer right away, but at least have some ideas of where this all can go and whether or not this problem is likely to be, or this conclusion is likely to be statistically significant or not. And especially it'll be beneficial when, or if you are already, or when you become like a manager, if that's your goal, or like an executive, because sometimes you just won't have time to write those things out, but you can look at results that are being presented to you, and you can assess those things in your mind very quickly. Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.